All right, so as promised, we are going to make a video about the law of sines. So basically, what we've covered is 6.1, 6.2, a very small part of 6.3. We're not going to do 6.4, hardly ever come up. 7.1 is law of sines. That will come up occasionally, so I do want to cover it. So what is the law of sines? So we had actually the law of sines in geometry. So this was a way of solving oblique triangles. Really, all we've talked about, we've talked a lot about right triangles, but we really have looked at other angles and defined angles in different ways. But oblique triangle is just a triangle that is not a right triangle. So is what I mean by an oblique triangle. And law of sines really is used for that. If it's a right triangle, you would just use your regular trigonometry to go through and solve that. But let's do say that we have a typical setup for this law of sines here. And I typically label this big A, big B, big C. Those big capital letters are used for the angles. And then opposite big A by convention, we're going to put our little a, right? So our little a is opposite our big A. And then our little b is opposite our big B. And our little c is opposite our big C. So I have this triangle here. Now, what we actually know about this triangle is this relationship, which I'm going to call the law of sines. And this says that the sine of A over little a is equal to the sine of B over little b is equal to the sine of C over little c. Okay. So really when I look at this, what this means is that, say, the sine of A over little a is equal to the sine of B over little b. Right? There's three different, really, equations that we're talking about. So I know sine of A over little a is equal to sine of B over little b. I know that the sine of big B over little b is equal to the sine of big C over little c. And I know that the sine of big A over little a is equal to the sine of C over little c. Really, it's the same rule. We're just saying that the sine of an angle over its opposite side is equal to the sine of an angle over its opposite side. Okay. So that is the way that we're going to write it up. And I hope that you see that. I'm just going to do some examples. With the labeling, we're going to label stuff to write down what our answers are. I won't label it typically too much, though, if I don't need to. Okay. Okay, so let's take a look at a problem here. I'll show you what I mean. So number 4, and this just says to find side A. So find A, little a, and they give us this triangle. And I got 45 degrees, and I got 10, I got 105 degrees up here, and I have C, I have little a, I have big A, I have big B. Okay, I think I've got everything written down now. All right, how would I go about finding little a? Just by using this law of sines. So without overcomplicating the picture, what I'm saying is that if I look at the sine of this angle, say 45, so the sine of 45, what's the side opposite this angle? That would be A. So the sine of 45 over little a, and that's equal to the sine of this angle over 10. So I would need to go through and find this angle before I did anything, right? So what does angle B? That's 180 degrees minus 105 minus 45. That's going to be 30 degrees. So sine of 45 over A is equal to the sine of this 30-degree angle over the side opposite it, which is 10. So I just set that equation up. And then I have a proportion. I would just go through and solve for A. So by cross multiplying, guess we're not cross multiplying with that marker. So cross multiply, so I got 10 times the sine of 45 is equal to A times the sine of 30. Now, either you can do this by plugging in the values because you actually know what these are, or I can plug them in a calculator. Let me point that out. Okay, so let me kind of write this out in two different ways. So this way, maybe the way you're more comfortable with, I would just find A by dividing by the sine of 30 degrees. So, and you would pop that in a calculator, and that would get you, I believe, to get you 10 root 2, but I'm gonna verify that over here. Okay, so right here, I could plug in what I know. What's the sine of 45 degrees? Well, that's root 2 over 2, right? What is the sine of 30 degrees? That's 1/2, right? So I really have 5 root 2 is equal to 1/2 A. If I multiply by 2, 2 times 5 root 2 is equal to A. So A is 10 root 2. Now, are we typically going to be able to actually write it out like this on the left? No, because I usually don't have special angles in my triangle. That's kind of unusual to have that. So typically it's going to be this method on the right with the calculator and like rounding to the nearest tenth. This one I can actually find the exact answer. And since they say don't use the calculator, we're just going to use that. Okay, let's look at another one. So, number 8. So this one, so I got B, I have A, I have C. And I want to go through and find all the missing angles inside. So this just says solve. If I have one that says solve the triangle, I go through and I use, and I go through and find the missing angles and sides. Okay, so one other thing I was going to point out, you may have, when I lump the law of cosines in this, you may try to determine whether or not to use a law of sines or cosines. So law of sines, I would use that one if you have something with angle, angle, side, or angle, side, angle. Okay, and here, like this one, I have angle, angle, side. This side's not between these two. So this one would be a good law of sines question. Basically, if you have two angles, I would use law of sines. I would start with law of cosines if I have something like side, 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 or side, angle, side. Okay. There's also a section that talks about the side, side, angle case. That's 7.2 that we're not going to cover. Okay, I'm just more concerned about this traditional, more likely scenario here. Okay. So in this one, I would use law of sines because I have that angle, angle, side case right here. So what could we find first? Well, I could find this big A, right? So that A is just 180 minus 18.7 minus 124.1, and that's all we would do there. So I got 180 minus 18.7 minus 124.1. That's 37.2 degrees. And then what are my missing sides? Well, I'm missing my little a here, and I'm missing my little c here. Right? So I would like to set up equations to go through and find those if I can. Okay, so let's try to find, say, little a. To find little a, I could do, say, the sine of 18.7 degrees over the 94.6, so over its opposite side. And then I could either use sine of 124.1 over c. Well, that's going to have a variable in it that I don't have, so I could use that to find c first. But I think I said we're going to find little a first, so I'll use this one, sine of 37.2 over little a. Notice I can take this equation and solve it for little a here. Okay, so all I would do is cross multiply. So I got a times the sine of 18.7 is equal to 94.6 times the sine of 37.2. And then I would divide by this sine of 18.7 to get a. So little a is 94.6 sine of 37.2 degrees divided by sine of 18.7 degrees. And when you're putting in this expression, make sure you're in degree mode because that's sine of an angle in degrees. So you're literally putting it in like this, like 94.6. Sorry. 94.6 sine 37.2 over sine of 18.7. And checking your mode is in degrees. Okay, 178.4. meters. Okay. What about little c? Okay. What is the equation for that one? So equation there, you could use the same one here. Sine of 18.7, you could use over 94.6. And then you could use sine of 124.1 over little c. And that will find little c for you. Okay, so I'll let you solve that one and punch it in the calculator and see what you get to make sure that you're going through this right. Okay. You got like 244.3 for that one. Meters. Okay. I think I could sit here all day and do those. I think that should be enough to get you through that law of sines part if you kind of look at those two examples. Okay, if they say solve, they're asking to find all the missing angles and sides. And if they say, just find the side, then you're just finding that side. Okay, so I think I'll stop there and we'll go on and we will look at section 7.3.